Hello, students. Today is practical lesson 1 by discipline interchangeability, standardization, and technical measurements. Task 1, clearance feet. The connection size is set. Diameter 12, nominal diameter 12 millimeters. Upper limit deviation of the hole plus 0.018. Low limit deviation of the hole is equal 0. Upper limit deviation of the shaft minus 0.016 and lower limit deviation of the shaft minus 0.034. So define first hole and shaft limit dimensions. Second, hole and shaft tolerances. Third, limit clearances or interferences. 4, feet tolerance. And 5, draw a feet scheme indicating all those parameters that define in item 1, 2, 3. So let's start. Solution. First, hole and shaft limit dimensions. As you can see, upper limit deviation and lower limit deviation of the hole, upper limit deviation and lower limit deviation of the shaft. So upper limit deviation of the hole, big S, is equal plus 0.018 millimeters. Lower limit deviation of the hole, big E, is equal 0 millimeters. Upper limit deviation of the shaft, small es, minus 0.016 millimeters. Lower limit deviation of the shaft, small e, minus 0.034 millimeters. Maximum hole size. We use the formula d suffix maximum is equal d nominal plus upper limit deviation of the hole. And d nominal is equal 12 millimeters plus big ES plus 0.018 millimeters. 12 plus 0.018 is equal, and we have 12.018 millimeters. Minimum hole size. D suffix minimum is equal D nominal plus lower limit deviation of the hole, big E. And we have 12 plus 0, big E is equal 0, and we have 12 millimeters. Maximum shaft size. So small d maximum, suffix maximum, is equal nominal diameter plus upper limit deviation of the shaft, small es. Small es is equal minus 0.016. So we have 12 plus minus 0.016, and we have 11.984 millimeters. Minimum shaft size, d suffix minimum is equal nominal diameter plus lower limit deviation of the shaft, small e. And 12 plus minus 0.034, minus 0.034. And we have 11.966 millimeters. Hole and shaft tolerances. Second item, hole and shaft tolerances. We use the formula. Hole tolerance, big TD, is equal upper limit deviation of the hole minus lower limit deviation of the hole. And we have 0.018 minus 0, and we have 0.018 millimeters. Shaft tolerance, TD small d. is equal upper limit deviation of the shaft minus lower limit deviation of the hole. And we have minus 0.016 minus, and one more minus 0.034. And we have plus 0.018 millimeters. It's shaft tolerance. Next, item limit clearance or interference. Limit clearance interference. We have clearance feet, so we should find maximum clearance and minimum clearance. Maximum clearance, S maximum, S suffix maximum is equal upper limit deviation of the hole minus lower limit deviation of the shaft. Big ES minus small e, big ES plus 0.018 minus small e minus 0.034. And we have plus 0.052 millimeters. Minimum clearance, S suffix minimum, is equal lower limit deviation of the hole minus upper limit deviation of the shaft. And we have 0, minus, and one more minus 0.016. And we have 0.016 millimeters. Fit tolerance. Fit tolerance is equal the sum of hole tolerance and shaft tolerance. Big TD plus TD small. And we have 0.018 plus 0.018, and we have 0.036 millimeters. And 5. Draw a fit scheme indicating all those parameters that define in item 1, 2, 3. The first scheme, the fit scheme, 0 line, plus minus, nominal diameter 12 millimeters, tolerance field of the hole, big ES and big EE, big TD, tolerance field of the hole, and tolerance field of the shaft, small ES, small EE, small ES is equal minus 0.016 minus 0.034, it's small EE, lower limit deviation of the shaft. It's the fit scheme. And the maximum, maximum hole size, big D, minimum hole size, maximum shaft size, and minimum shaft size. It was the first scheme, clearance fit. Next type, it's maximum clearance and minimum clearance in the scheme. Task 2. Interference fit. We have connection size is set, nominal diameter 300 millimeters, and above the line we have upper limit deviation of the hole 0.081, and lower limit deviation of the hole is equal 0. Upper limit deviation of the shaft, it's under the line. It's equal plus 0.431, and lower limit deviation of the shaft is equal plus 0.350. Define the same parameters. First, hole and shaft limit dimensions. 2, hole and shaft tolerances. 3, limit clearances interferences. 4, fit tolerances. And 5, draw a fit scheme indicating all those parameters that defined in items 1, 2, 3. And we have solution. First, hole and shaft limit dimensions. Upper limit deviation of the hole we have in this task. It's equal plus 0.081. Lower limit deviation of the hole is equal 0. Upper limit deviation of the shaft, small es, is equal plus 0.431. Lower limit deviation of the shaft, EE, is equal plus 0.350 millimeters. Maximum hole size, D suffix maximum is equal nominal diameter plus upper limit deviation of the shaft, of the hole, big ES. So nominal diameter is equal 300. millimeters plus 0.081, and we have 300.081 millimeters. It's maximum hole size. Minimum hole size, D minimum, nominal diameter of the hole plus lower limit deviation of the hole. 300 plus 0, we have 300 millimeters. Maximum shaft size, small d maximum, is equal nominal diameter of the shaft plus upper limit deviation of the shaft, small es. 300 millimeters plus 0.431 millimeters, and we have 300.431 millimeters. Minimum shaft size, d suffix minimum, d nominal plus lower limit deviation of the shaft, and we have 300 plus 0.350, and we have 300.350 millimeters. It's minimum shaft size. Hole and shaft tolerances. We use the formula for the hole tolerance. Big TD is equal upper limit deviation of the hole minus lower limit deviation of the hole. And we have upper limit deviation of the hole plus 0.081 minus 0, and we have 0.081 millimeters. Shaft tolerance, small TD is equal small upper limit deviation of the shaft minus lower limit deviation of the shaft, and we have 0.431 minus 0.350. It's equal 0.081 millimeters. Item 3, limit clearances or interferences. We have transitions feet, so we must find, we have interference feet, so we must find maximum and minimum interference. So maximum interference, n suffix maximum, is equal upper limit deviation of the shaft minus lower limit deviation of the hole. It's equal 0.431 minus 0, we have 0.431 millimeters. Minimum interference, n suffix minimum, is equal lower limit deviation of the shaft minus upper limit deviation of the hole. Small e, let's see, is equal plus 0.350 minus big ES, plus 0.081 millimeters, and it's equal 0.269 millimeters. Feet tolerance is equal tolerance field hole tolerance plus shaft tolerance, big TD plus TD small. Big TD is equal 0.081 millimeters, small 0.081 millimeters too. So we have it's equal, this sum is equal 0.162 millimeters. And fifth item, the feet scheme. We draw zero line, plus minus, nominal diameter 300 millimeters. Tolerance field of the hole, upper limit deviation plus 0.81, lower limit deviation 0, and tolerance field of the shaft, small TD small. Upper limit deviation small es of the shaft is equal plus 0.431 and plus 0.350, it's lower limit deviation of the shaft. Maximum hole size, D maximum, minimum hole size, D minimum, maximum shaft size and minimum shaft size, minimum interference and maximum interference. That's all what we need to do in task 2. And let's start task 3. Transition feet. The connection size is set. Diameter 140 millimeters. And we have upper limit deviation and lower limit deviation of the hole, upper limit deviation and lower limit deviations of the shaft. Define the same parameters, hole and shaft limit dimensions, hole and shaft tolerances, limit clearances, or interferences, fit tolerance, and fifth, draw a fit indicated all those parameters that define in item 1, 2, 3. Solution: hole and shaft limit dimensions. Upper limit deviations of the hole. Big ES is equal 0.02 millimeters. Lower limit deviations of the hole, big EE, is equal minus 0.043 millimeters. Upper limit deviations of the deviation of the shaft, small ES, is equal 0 millimeters, and lower limit deviation of the shaft, small e, is equal minus 0.040 millimeters. Maximum hole size is equal nominal diameter plus upper limit deviation of the hole. Nominal diameter 140 plus 0.02 millimeters, and we have 140.0 140.02 millimeters. Minimum hole size D, big D, suffix minimum, is equal nominal diameter plus lower limit deviation of the hole, small big EE. Nominal diameter 140 plus big EE minus 0.043 millimeters, and we have 139.957 millimeters. Maximum shaft size, D maximum, is equal nominal diameter plus upper limit deviation, and we have 140 plus 0 is equal 140 millimeters. Minimum shaft size, D minimum, is equal nominal diameter plus lower limit deviation, and we have nominal diameter 140 plus minus 0.040 millimeters, and we have 139.96 millimeters. Hole and shaft tolerances. Hole tolerance, big TD, is equal big ES minus big EE. It's equal 0.02 minus 0.043 millimeters, and we have 0.063 millimeters. Shaft tolerance, TD small, is equal upper limit deviation of the shaft minus lower limit deviation of the shaft. 0 minus 0.040, and we have 0.040 millimeters. Limit clearances or interferences. For transition fit, we should find maximum clearance and maximum interference. So maximum clearance is equal upper limit deviation of the hole minus lower limit deviation of the shaft. Big S is equal 0.02, and small e minus 0.04. And this, when we find this formula, when we calculate this formula, we will have 0.06 millimeters. Maximum interference and max and suffix maximum is equal upper limit deviation of the shaft minus lower limit deviation of the hole. Small ES is equal 0. Big EE minus 0.043. And we have 0.043 millimeters. Fit tolerances. Fit tolerances is equal big TD, hole tolerance plus TD small, shaft tolerance. Hole tolerance 0.063 plus 0.040, and we have 0.103 millimeters. And the fit scheme, zero line, plus minus, nominal diameter 140 millimeters, tolerance field of the hole, upper limit deviation, lower limit deviation, upper limit plus 0.2, lower limit deviation minus 0.043. Its tolerance field of the hole and tolerance field of the shaft. Upper limit deviation of the shaft is equal to 0, lower limit deviation minus 0.04, and its tolerance field of the shaft. Maximum hole size, minimum hole size, maximum shaft size, minimum shaft size, and maximum clearance and maximum interference. That's all what we need to do in this task. So it was example, 3 examples, and now you should do your individual task. Use your variant like the number of your journal in your group. So use variant 1, 2, 3, 4, 5, 6, 7, 8, 9. Choose your variant and calculate all these parameters: hole and shaft limit dimensions, hole and shaft tolerances, limit clearances, feed tolerance. Draw a feed scheme indicating all those parameters that define in item 1, 2, and 3. Do it now.